TBAnalytics is just a term we use to regroup all kinds of things we can do in the system, like call trace and test call. So some of them we have seen already, but I'm just again going through all of them to make sure we have covered everything. So from the main page of the system, you have the status. You can see the colors here to see if it's running fine or not. You can see if you're on the system tab, some information about the system, the version you're running right now, if you are a standalone host or primary or secondary host, the one you are connected to. And you can have a good idea on call rate here of the system. Okay, so number of answered call, currently highest that you have seen forever. So you have an overview of this here. The other status you can see on the same page is the database status. So you can see your configuration database, is it running on the primary as slave or as master? So you can see this here, how it connects also. And here it's going to use the control 0 and control 1 networks to reach the slave database. Okay, so connection is with the internal IPs. If you have just a standalone system, of course, you will have only one of those devices shown here. In the host section, we saw here you can get the features that are supported by this SBC, the product key of the SBC, which is important because that's how we reference it in our internal systems. Status of the servers. You can see, you also have here commands on the units, like I showed you beginning of this presentation today, how to reset the roles. So if you want to change from standalone to 1+1, you can do this here. If you want to change the network interface roles, you can do this here as well. You can shut down the servers at this level, or even upgrade the CentOS kernel. If you click on features here, you will see what is available. Now, almost the only one that is important is the SIP calls here, that will tell you how many calls you can do in the systems. And you see these are not sessions, these are calls. So that means for one session, you will use 2 calls. This one has 10,000 sessions available. Right? All the other parameters, if you have ProSBC, are enabled automatically. If you're using FreeSBC, well, some of them are not available, like analytics is not available. And then you have the date here. That's when the next time you'll need to update the license. Yeah, so this snapshot was taken before it expired. So otherwise it would say expired through here on this system. Okay, and you know each of these modules, what they include. Okay. Then the processor usage. So I showed you that briefly just before the break. I think it's important to look at this, especially if you have if you need a high performance out of the system. All right. So first you will see the packet processing. So this is the number of packets processed by TB router. So this is in total, and this is per interface. Okay, so you see that there is 1 core associated with the processing of these packets. Okay. This will go up if you have a lot of RTP traffic through the system, or if you need to do RTP to SRTP conversion. Okay, so this will be used on the system. Then you have applications. Here it's the global application information, but I think it's better if we do it here instead. If you click on applications, you will see each one of these applications that are in use in the system and what is the CPU usage of each one of them. Okay. The ones that are really important are these three, because there are cores or threads associated with specifically those applications. And you see gateway can only run on one single core. Right? When your system is in high load and your call rate is very high, this may come up close to the congestion limit that you have on the system here. Okay? So you need to monitor this, and if you get too close to the limit, we may need to think of either optimizing the system or in the end, maybe changing the server so that you can get more performance. If you have a transcoding unit, all right, so yeah, so by default, there's no transcoding unit on the system, on the systems, and you need to tell in the configuration profiles that you want to see this. So there's a procedure to do that. It's just one checkbox you have to add in the system. And once you've done that, then you will see an additional parameter that's called hardware units here appear. And that means you can add a transcoding device to the system. Right? When you have added this transcoding device, and if it's connected to the SBC, you will see it appear here, and you will be able to see the state of that hardware unit. Yeah, there's not a lot of information here, but one of them is if you want to reboot the unit. All right, so you have the option to do it here. And in usage here, if you have transcoding being used on the system, this value here will go up. Okay, and this is in percentage of the total voice over IP transcoding devices available on the system. So you can see here if how you are running in percentage of the total voice over IP traffic in the system. So let's say you have a transcoding device with 2,700 transcoding resources, and you are using maybe half of it. Well, you should be close to 50% here on the voice over IP device usage. You have some information also in the network access points, some status there. You can see if it's available. So you see here if it is available and if you are polling the remote side. Okay, if you want to do registration, so if you want to register to a carrier, then you can configure it. If you configure it, this is going to be yes. And then, of course, it's going to show if you are registered. And then you get all kinds of information like instantaneous incoming call count, in progress, answered. You have the ASR. So answer seizure ratio value here for the last 24 hours, last hour, current hour. So you can see these information being shown on the status. All right, so you get status, and we saw the status from the SBC. You can see the status from the SIP, the registration status. Okay? So you can see status from a lot of services. So this will usually give you a good view of how stable is your system. And if you have errors, they should show in one of those statuses. Now, we talked about call trace, and it's an important tool to see what is going on the system. So you have a graphical view of the call flow of what is going on in your system. You have up to 50,000 sessions quickly available from this tool. You will store these information in the directory we showed you earlier on. Okay, the files will be called UCT data files. And you can search in this tool by date, time, and all these parameters here, the NAP, the route name, the call ID even, the reason, either not normal or a specific reason cause. You can say any calls that is more than 30 seconds or less than 30 seconds. So you have all kinds of tools here to filter and find the calls you want. Yeah. So you will see your list of calls like this. So you will see when the call came in or went out. So you see incoming call, outgoing call. And you can see here from which network access point the call was received or to which network access point the call is going to. And then the called and calling numbers that are used incoming and outgoing, and which route was taken for this outgoing call. So if it's an incoming call, you don't have a route, but if it's an outgoing call, you will see which route was taken. That's the route in the routing table. You have a name there, and it's going to be shown here. If you continue there, you have the reason for the failure or the why the call was stopped. Maybe 302, 480, 31. So you have those errors being printed here. If the call was answered, there will be a MOS score associated with that. And you will see the call ID being used for this particular call as well. In the summary, so if you click on one of those entries, you will see the call that came into the system from which network, and you will see the outgoing calls that were made. So here there were 2 calls that were made. You will see in that call trace the messages that are exchanged. You see the call ID, the incoming IP and port, outgoing IP and port. Whoops, sorry, that's the remote port and the local port. Then you have here the RTP port that is being used, the IP of the RTP, and then you have the port of the RTP. You have the codecs that are being chosen for this particular call. You see the profile that is used, the call number, calling number, and you have a list of information that is being displayed here. What I did not show is it also shows call recording, if there was call playing, and yeah, so there's more information than what I've shown here. To change the number of files or number of calls and the size of the files that are stored on the disk, you can go here in Applications. Then you select TBUCT Writer, and you can change the maximum compressed directory size that will be used. So that by default, it's 100 megabyte, but you can change that if you have enough space on the disks. And then maximum calls, here it says 10,000, but you can change that to a value up to 100,000. Okay. Then you have the location of the recorded call traces. So you see it's called UCT data files. Okay. So these files can be extracted from the system. Other questions on call trace? It's okay. And I showed you how to retrieve the call trace in the on the wiki. It's described how to do that. Recording. So if you have a transcoding unit, you can do recording. There's two ways to do recording. One of them is from the web portal, and the other one is from the routing scripts. So from the web portal, you can go here in Gateway, select Enable Call Recording, then select some parameters like a regex on the call number, value or a regex on the calling number. You can select a specific incoming NAP or a specific outgoing NAP. Okay, so in this case, if the call comes from SIP provider 1, it has this calling number and it's trying to call a number that starts with 800, it will be recorded. All right, so if it is recorded, then it will be stored on in a particular directory, which is shown here. All right. So you see the beginning is always the same, right? It's always the same part that starts, and then you have recorded calls. And if it was recorded, it will also show up in the call trace, and you will see download audio file, and you can download the files, the recordings from both legs that were done. All right. So when you select recording from the gateway application like this, it will automatically record all the calls that match these rules, and they will be stored on the disk. Okay, so you need to either retrieve them or remove them at some point. Otherwise, they will be just overwritten in the system. If you want to use the routing scripts, well, I showed you yesterday a brief explanation on that. You have to use the bridge parameters, and you have to say, I want to record this call. So it's bridge parameter, record, and then it will record the file that matches whatever you have put in the routing scripts. Okay, so of course, routing scripts are very flexible, so you can just decide what you want to record in there. And you just need to add a bridge parameter that says, I want to record. Okay. Okay, the other tool we have is test call, and this will generate a real call on the network. All right, so it's gonna, from the SBC, it will generate a SIP call that will go out on the network. You have two modes you can use. You can use either outgoing call or you can use incoming call. If you use outgoing call, you can use it to simulate different call flows going out or just verify the interconnection on the destination. Will it answer when I send a call to that particular destination? You can also simulate an incoming call. When you simulate an incoming call, it will do more things. Okay. One is you will verify your routing table. You will verify your routing scripts. You will verify if you have route retries. Okay, so you will see all the routes that are being tried. In all cases, you can verify some call parameters, and you will get also a live call trace status on there. Okay. So just to repeat, if you choose outgoing, it's going to make an outgoing call from the SBC out. If you choose incoming, it simulates an incoming call, goes through the routing script, and then goes out to the destination. Okay. Again, it's a real call that is created here. So you choose here, generate outgoing call or simulate incoming call. And here, depending on what you have chosen here, the value of the NAP is different. Okay, so if you choose outgoing, this will be the outgoing NAP. If you choose incoming, this will describe the incoming NAP. Then you can simulate which numbers you want to use for this call. If you have transcoding available, you can play a file. So it's going to make a call and play a file. So someone will be able to answer and hear something from the system. Also, if you have transcoding, you can record what is coming from the remote leg. Okay. In this portion here, you can add additional call parameters. So if you want to test sending some specific parameters in the SIP call, you can add this here. So this is just an example of having a private header called xOriginIP, and this will be inserted into the SIP call outgoing. Then when you do place call here, it will show the call trace status here. It will show, I mean, trying to make a call here. This is the call number we use. This is the calling number. And if it was accepted, it will be shown down here. Okay. But this, like I said, I repeat, this test call is making a real a call in the system to verify if the connection is available and if the RTP path is available if you have the transcoding devices. Signaling trace. Right? So you can capture signaling traces from the system. It will capture only SIP traffic in the case of the SBC, and it will create these files that you can read with Wireshark. You need to get SFTP. You need to use, SFTP to get the files out of the system, or you can use P-Link to get direct signaling trace to Wireshark. So I talked to you about this a little bit yesterday, and let me just see. Yeah, okay, I will show you how to do this. Okay. So the first procedure is just to connect SSH to the unit. So you connect to the console of the unit. You start the TB-SIG-trace application, either TB-SIG-trace or TB-SIG-trace-IP. Once you have captured all the SIP traffic you want, you can just type Q to stop capturing traffic. And then the file will be located, you see again at the same path, but it will be now in the TB-SIG-trace folder. Once you have those files, you can just open them in Wireshark and you'll see the SIP trace. The SIP can be filtered, of course, with certain filters in Wireshark. So here I just give some examples that can help you to filter the calls. Okay. Then you have the live capture. So instead of using the procedure I just showed you with the SFTP and stuff like that, you can use the P-Link application. P-Link is created by the same team as PuTTY, and you can execute a command to capture the signaling, and the command looks like this. So you just have to be careful when you create the command because it's easy to make a mistake. So once you've downloaded P-Link from the network, you can do P-Link here, and then you use the SSH protocol to reach the device, and with the user, IP, and password. Then you start the TB-SIG-trace application. And here it says, you see, there's an additional parameter to TBasic trace, meaning std out. So that means send it to the incoming console. And then you pipe it and you specify the path of your Wireshark application. And then you pass some parameters to Wireshark -k, -i, and dash. Okay? So once you run this, immediately the Wireshark pops up and you get traffic coming into the system, coming into the Wireshark, and you can see the live calls of the system. Now, it's possible that if you have some traffic that is running not in different applications, but it's running on the management port, then maybe you need to do TCP dump to have the output on the management port. So TCP dump is like this. The only thing you have to change from the regular TCP dump is this dash here at the end. Okay, so this is -w -write to the input, and then you have the same command here, and then you'll capture everything that goes out on management 0 here. So for TBasic trace, is it possible to have filtering a certain NAP only or certain calling number only? So let me just check. Let me just try something. No, you cannot. Yeah, no, you cannot. So no, you can only capture everything. Okay, so if you start it, it's going to capture all the SIP traffic, and then you need to filter it with Wireshark to stop it. Okay, all live traffic will be captured. That is correct. So if you do here p-link and you run the live traffic, you will see all the SIP traffic being forwarded to your Wireshark. So it may create a lot of traffic there. You can use Wireshark then to filter out this the calls you don't want, right? So of course for you, Rudy, it could be difficult, right? At 600 or 900 calls per second, it could be busy. And any workaround to do live trace with filtering? Well, I don't have any workaround for that. Okay. So that's one of the reasons we created the call trace tool. It is a bit more efficient than trying to capture all the SIP traffic. So it will compress what we receive, and we'll be able to keep more data for a longer period of time. Using TBasic trace or Wireshark like this is a bit more tricky because it can fill up pretty quickly if you have a high number of calls in the system. Okay. Then you have TB report. TB report is a tool to capture the logs of the system. When you face a problem that you don't know how to fix, and you want us to verify if we find any errors in the logs, you can send us a TB report. So when you click on this here, it's going to create a a zip file with all the logs from the dates you have specified here. And it will also take a configuration backup of the system. So we'll be able to see the configuration you have currently on your system. All right, so we can use this to check all the logs from the system. And a lot of time, when you report a problem, we will ask you to do this TB report. And we may also ask you to specify a call trace level, a trace level, I mean, for a specific application, so that when you do a TB report, you get more information. You have audit logs. So these are the logs done by users. So if you click on logs here, you will see audit logs, and you will see who has modified something. Maybe just a login or updated or activated the configuration. And then you can see what was changed. So this was a script file that was changed. This was a configuration that was updated here. So you can see that. If you click on show here, you will see data about what was changed. Okay. So attributes changed here, and then you can see all the attributes of that specific log. Okay. So you can also download those logs out of the system to see what was modified. Other troubleshooting you can do, well, you saw that, you know, many times we want to access SSH, but maybe also using SFTP to access the system, and of course HTTP or HTTPS. This is where all the applications are running. You saw that already. And there's, once you get on this server, then you have the CentOS commands, right? Like ifconfig to see the internal interfaces, yum update to update the Linux host. You have var log messages, which has global system images, like when it was powered up, Ethernet, physical Ethernet device status. So you can see those data. You can use the application top to see the CPU and memory usage, but as I told you, you have to be careful here because it doesn't always show the correct information, especially for the TB router application. And all these applications run behind a service, which is called TB Toolbank. And then you can manipulate this service. You just have to be careful here because you may want to, when you do stop, you will really stop all the applications running on the system. Okay. And other useful commands I showed you already quickly. TB setup gets you to the current log directory. TB bin gets you to the current applications. So these are the binary of the applications. You have information on system errors using journal CTL. You have information on interfaces using LSPCI. And specifically TB router, the logs are located at a different location than all the other logs. And this is the folder this is the folder that where the logs are. Okay. So the configuration database, it is managed by the web interface to do a TB status, a TB backup, I mean. Okay, so you do a backup of the system there. But if you don't have access to the web interface, you can do a manual database backup. Okay, so the command is here, MySQL dump. Okay, and then you just need to use the right version of the database because every time we change a new major version, this will change. So maybe it's going to be 3.0 or 3.1 or 3.2 later on. This database backup will be available in the TB report when you do that. And we can load it on another unit to see the configuration of the system. If you are familiar with MySQL, you can access the database like this. Things that we do sometimes on our side is just update the password so that we can log into the system. When we take the database from a customer system and load it up on one of ours, we can log in using this command here. So this is a useful command. And then we have this tool here that we have used many times already in these few days. It's a Runtime Log Viewer. So you see the logs printed immediately from any of these applications. You can select which application to monitor by using the arrow key, right? Or you can just press the letter of the application. And you have to be careful because you gain the full control of the application. Okay, you can do some real-time commands on the applications, but you also have to be careful because you have full control of that. To exit the application, you have to press escape twice. Okay, and whoops. And you see here it says at the top, press escape twice to disconnect from this application. All right, so we saw this many times. You can log in here. Here to change which menu you're looking at, you can press tab and you will see some information on each of these applications. But I think the most important part here is the logs that are being shown here on the bottom, and you will see what is going on. Then to capture all the packets that pass through TB router. So you saw in the SBC detail presentation that TB router is running at a separate part of the software, and it has access to the RTP traffic, SRTP traffic, and also any block traffic will also be sent to TB router here. Okay. So you need to use the same tool, TBXCLI tools remote, TB router, P to start capture, P to stop capture. As we were discussing with Rudy a moment ago, it will capture everything unless you filter, and the filter is very minimal, either the VLAN ID or just one way, all right? But there's not a big filter on that. You will capture everything that goes on. So usually you should try to capture a short period of time and try to reproduce quickly what you need to reproduce so you can quickly filter out anything that is unnecessary and get only the part of the traffic you want. And then once you have done this, the system will tell you the path, the exact path of that file. You will have a date on the file and stuff like that, but you can see it here if you don't have that. Okay. I mentioned the nic.json in the SBC details. So that is used to control what the network interfaces will do on the system. And it has some things that can be optimized. Okay. So for example, it defines the network interfaces and the CPU cores that are assigned to each one of those network interfaces. Then it has the role. Okay, so the role can be LAN 1, it can be management, or it can be control 0, control 1. Okay. And then the core is which CPU core is used for this process. So in that file, you really specify what is the core that is being used for processing these packets. Okay, and there's a special command here that shows the drivers that are being used. So you see the ones that are shown as DPDK. So these are the ones that are called LAN1. And the kernel drivers are the CentOS drivers. So you see these are two separate interfaces. Some of them are used by TV routers. Some of them are used by the CentOS operating system. And monitor is a good question. I don't know what that is. I don't know what that is. I always use full capture. I never use anything else. So I'm sorry, I don't know. And then the other question was, is it safe to increase TV router capture buffer, for example, 128 megabyte? I think the maximum is 256 megabyte rotating buffer. So, maybe it's more than that, but yeah, I think if it's there, it should be okay to use that. It could be 512 megabyte or something like that. If you have transcoding units, the difference here is that normally you don't need to access them because they will be auto detected in your network because it uses well-known IP addresses that are recognized by the servers. And but if you need to access them, then you can use a telnet to access them. So it's not using SSH, it's using telnet. And there's a few commands like print info will tell you how many devices are available on that particular transcoding unit. Print boot will tell you which version it's booting on, and you can get other information about the network interfaces there. But most likely you will never have to use these type of commands on the transcoding devices. Okay, so that goes through the overview of the the tools to debug. Let me just try. I'm curious to see TB router. If I do P, what can I use here? You see, the snapshot I have taken for the presentation is old, right? The capture mode mask is not monitor. It's in, out, or in. It's in, or it is out, or it is in and out. So monitor doesn't exist anymore. Yeah, and here 256. And if I do 512, yeah, so 512, I think, yeah, 512 is not good. Yeah, okay, so 256 maximum. Okay. Yeah, it seems to have stopped. Or I think that it's not crashed, it's just too busy, right? Manipulating the buffers. See, the application is still running. It's just busy processing the traffic. When no traffic. Okay, so okay, wait a second. Let me go back here in the host. So the question relates to this, the processor usage. Why does it say 120%? Yeah, here I think that for some reason it can use a bit more than one CPU. Okay, so I don't know exactly the reason for this, but it looks like it can reach a bit more than one single CPU core. Okay, so I'm not certain of why it does that, but it looks like it can do it. Okay, so I don't have the real reason for this. When no traffic, sometimes midnight TB router will go 100% usage. What may cause it? I have no idea. And when you say 100 usage, you mean in packet processing here, it goes to 100%? Yeah, I don't know. I'm thinking maybe it could do some what do you call, garbage collection or something like that. But I don't know specifically why. I think if you encounter this every day, but when there is traffic is back to normal, I don't know. I don't know. We could verify on your system why you're getting 100% here. Okay. I see it when I do some stress testing. I see it increase to, let's say I have one core handling one gigabit interface, then I can see it going about to 20% usage. And I'm guessing that if I put 5 network interfaces, well, I will be close to 100% usage when I blast out on those 5 gigabit ports. Okay, so why does it go to 100%? I don't know. I don't know. But we can certainly figure it out if we get enough information.